Right, we missed quite a. Okay.
Yes, let's get started otherwise. Okay. Now, hi, good evening. We are going to work on basically object-oriented concept. I know you all know in depth what is OOPS and how do we use OOPS in the overall programming part now, because these are the questions asked in the interview. So we need to work on it. We need to really think it through from the angle of clearing the interview, right? So please stick to the definition if possible. Try to write it down a couple of times and be ready whenever the interview asks, so that you can answer with full confidence. Maximum interview 80% plus, they ask you question at least one or two on OOPS, object oriented programming. It's basically a kind of method of structuring program, use some code reusability, making sections of a program to be used better and later whenever we need, so that we don't have to program throughout every time, and we can just reuse the code. We can just create some sort of abstractions, inheritance, and all those things as well. So OOPS does help us a lot, and the code also becomes more maintainable if you have OOPS implemented in it. So normally in OOPS, what we have a base layer, normally referred as an abstract layer in a programming language. We normally derive our classes from that, and then we create objects whatever we need and use the methods inside them. Okay. Now I'm speaking more of from a Java terms, and Python uses more of a Java terms rather than C++. In C++, we have class derived, object have functions in it. So in C, we normally refer methods as a function. So there are many scientists who refer methods as a function or function as a method. So don't get wobbled or distracted by these things. You can use either words. And then of course we have all those restricted inheritance. We have encapsulations, inheritance, and all those things. So let's have a look at this terminology once again. I know this is more of kind of revision for you, but please bear with me for 10-15 minutes at the most, and then we'll shift to something called mathematics statistical terminology to understand, so that we could really understand when the other data scientist discusses solution, discusses their already created work with you, and they most probably use these statistician terms. So we need to refresh on them as well. I know ma'am have already worked on statistics, so it is going to help us out. If I miss anything, please do guide me, and we're going to learn this thing together. And as we all know, statistician mathematics is ever growing branch, right? So we have all different type of formulas, equations combined into our software solutions, and that's the fun of data scientists. That's why we are mathematicians. That's why we are scientists than a developer. And for the developer, we normally had these. Even you can call this as a mathematical model of programming, as an OOPS, but normally they are referred as OOPS, object-oriented programming. Okay, let's have a look at it from a Python perspective. Object-oriented programming is a method of structuring a program by bundling related properties and behaviors into individual objects. What does this mean at the ground level? We derive a structure of our program in such a way that we bundle together related object, and then we also bundle the behaviors they're going to perceive for us, they're going to show to us in the individual recurring programs again and again. So we bundle them, so we don't rework again and again. Once you created a work, you could leverage those works wherever you want to, and that's why we have this class layer created. The abstract layer normally is referred at. We inherit from that layer and then start using the behaviors or methods inside them to make sure whatever we want to do, we can do it with the least possible code rewrite or coding time spent or effort spent on that basis. Conceptually, objects are like the components of a system. Think a program as a factory assembly line of sorts. At each step of assembly line, system component processes some material, ultimately transforming the raw material into a finished product. Think it as you're trying to you are working in a factory which creates buckets, right? Buckets or small type of plastic pots, right? So what we do, we normally have plastic granules. We normally melt those granules, put the molded lava or molded plastic material into those molds, get them pressed, get them strengthened, get them cooled down, and then we have that mold with you. So something like that, we create mold. Once you have your mold ready, the repetition of our creation of pots every time is much easier. Or you can multiply by many of such rows so that you can create as many pots per second as you want. And it's just a simple process. Melt the particles, put it into the mold, press the mold, cool the product, and then you can have all those QC and Q&A on that product, and then release it to the market. So this way we can build repeatedly, multiply within a given time. So basically, what we do, we are trying to expedite the process of development without much effort. So we are trying to reduce effort on the one side because of the reusability, and you are trying to create multiple because of this shopping line type of approach we've taken in our programming. Does that make sense?
Yeah.
Great. Yeah, so let's go ahead. An object contains data like raw or processed materials at each step on assembly line and behavior like the action each assembly line component performs. So what is a method? Melting the plastic granules is a method. We do melt as per the need. If you need, let's say, 2 liters of the plastic liquid lava or liquid mold, you might just use so much grams or so much kilograms of this plastic granules. And as per our experiences, we know how much this, how much that, and the relation between that. So once you know the process, it's really it's really easy to use the reusability concept. So this way, what we do, we keep improving our creation rather than wasting time on development efforts. So we are trying to use reusability by reduction in a development effort, plus we can build quality, because whatever you do in those least amount of time, you can do it qualitatively so that the programming efficiency reaches new levels. And that's why we normally use OOPS. And as Python is a OOPS language, we should leverage all the linguistics features up to its best possible efficiencies. So that's why we use OOPS. OOPS is an approach for modeling concrete real world things. Like cars is, we have robots, and we can have robots building cars because we know the repeatability in the process. We know how an iron can be melted into some molds where we can create the body of car at one place, the basic car frame at other, and so on and forth. So this way we keep building and keep improving our rebuilding process, making it more efficient with less labor. Okay, that way, like cars, as well as I just discussed the plastic molding plant. Relationship between things like companies and employees, students and teacher, and so on. So we could use or reuse this once created program multiple times. OOPS models real world entity as software object that have some data associated with them and can perform certain function. So here we are talking about some basic structure already developed, and we add some structure on top of it whenever we want to reuse it in a particular customized way also. So like if you purchase a Tesla, I purchase a Tesla. You have a red Tesla, I have a black Tesla. Now, the way you customize your Tesla, like you want really good interiors with pink tint, because red car really goes with pink tint, and whatever colors you like as an interior. I might choose whatever I like as an interior because black interior doesn't sound good. So I might use gray, or I might as well use pink interior, depending upon my thought process, my need of the art in terms of utilizing the best possible or reutilizing the best possible car as per my needs. So this is what we call customization. So we do try to tackle the reusable object to best suitable for the current need, and that's the fun of OOPS we're talking about. Tesla might be manufactured some similar cars in the factory, but whenever you order something, they customize. The customization can be anything from 1% to 40%, depending upon the company, depending upon the reusability you have implemented in your solution. Does that make sense, ma'am?
Yes.
Yeah.
Yes.
I really have a good video to share with you on object-oriented programming, and luckily this is as we have seen, the program of basic, object-oriented programming implementation, how we have, those student marks categorization, gradation done with those example, right? So let's try to understand different property within OOPS. The first one, inheritance. As the name suggests, we inherit something. We inherit something from our father, forefathers, grandfather, and so on and so forth. So inheritance is a capability of one class to derive or inherit the properties of another class, what we call parent class. So this way, the class structure get derived from an abstract. That's what we normally refer as a first original class. Then we have second, then we have third layer, and so on and so forth. The last layer could inherit anything from the tree above. And that's the beauty of it. The class that can derive properties are called derived class or child class. The class from which the properties are being derived is called the base class or a parent class. Then we have polymorphism. Polymorphism is basically having many forms. You try to change or try to change the way the parent presents, right? It's like, we need to determine if we given the species of birds fly or not. Using polymorphism, we can do this by using a single function. Like, we have some birds. Peacock is a bird, which, couldn't fly as much as, the eagle does. We have sparrow who can hardly fly around 10 feet or 20 feet at the max, but still it's a bird, right? We have many birds like, ostrich, it can't fly. And something like that. So still, these polymorphism is basically, there are some properties which are get polymorphed, or which are get hidden, or which can be hidden into the derived class, and that way we can achieve polymorphism, just to make sure what all we are inherited can be stopped or can't be shown to anybody else as well. So it's a polymorphism thing. Then we have encapsulation. Encapsulation means we encapsulate the thing. Encapsulation is one of the fundamental concepts of object-oriented programming. It describes our wrapping data and the methods that work on data with one unit. This puts restriction on accessing variables and methods directly and can prevent accidental modification of data. In object-oriented programming, we have restricted methods usage. So there are some methods who are public, there are some methods who are private, and so on and so forth. So this usage of those methods in our abstract layer makes us more restrictive in their usage at a derived classes. That way we can really restrict the usage of methods throughout the hierarchy as well. So that's the beauty of encapsulation. To prevent accidental change, an object variable can only be changed by an object method. So we can restrict that variable within the method, so that it'll get reinitialized every time the method have been executed. Those type of variables known as private variables. So the life or the existence of private variable are limited to the method boundaries. Object-oriented programming makes the program easy to understand. It's readable, plus it's really easy if you know the abstract class layer well. If you know the parent class layer well, you can do really wonders with the object-oriented programming. Since the class is shareable, the code can be reused. That's the beauty of it. Data is safe and secure with the data abstraction. So you can encapsulate your data whenever you want to, whenever you don't want to showcase it to each and everybody. Polymorphism allows the same interface for different objects. So programmer can write efficient code. So one method can, one class can have different method with similar name, but still we can use it differently the way we want. And this way we can utilize polymorphism for our best usage. Does that make sense? Ma'am, do you have any question for me at this moment?
No, no, I
This
understand the concepts. Yeah.
is okay. Now let's try to understand classes versus instances. Classes are basically the original blueprint. Instances, we have derived an object from it. So it's one instance. I can derive as many instances as I want, and I can rename them as well. So for that matter, class is just a blueprint. The instances are the products of the classes. Classes are used to create user-defined data structure. Classes define functions. Well, we normally call it methods, which identify the behaviors and the action of an object created from the class can perform with its data. So once I created a class, I have created the basic design, the basic structure, right? Which I can inherit, I can encapsulate, I can polymorph, whatever I want. But still, the class is there. I normally don't disturb the class unless and until I have to. So I have a basic structure embedded into the class, and then I use derived class with modified customization. So my basic structure is still intact, and anybody else can use it. That's the beauty of OOPS. A class, as we discussed, is a blueprint for how something should be defined. It doesn't actually contain any data. Normally, it doesn't contain the data, but you can include data in a class as well. The dog class specifies the name and age of a necessary for defining a dog, but it doesn't contain the name and age of specific dog. So we can use class as a generic structure, the instances as a customized object as per your current need. And that's the best use of OOPS in our programming. While the class is a blueprint, an instance is an object that built from a class and contains real data. An instance of dog, the dog class, is not a blueprint anymore. It's an actual dog with a name like Miles, 4-year-olds, he's a Pomeranian or whatnot. So this way, I am customizing the class as per my need whenever I need. To put it other way, a class is like a form or a questionnaire. An instance is like form that has been filled out. Just like many people can fill out the same form with their own unique information, name, address, gender, photo, Aadhaar card, social security number, and so on and so forth. Many instances can be created from a single class. So when I need to create student, I'll just create student as a basic class, and then I can inherit student and fill in student 4th class, student 5th class, student 4th class name Ravindra, student 5th class name Vipasha, or whatnot. So this way we start creating these instances of a classes whenever need, and we'll start customizing it one by one. Does that make sense, man?
Yes. I understand.
Let's take a step further. Again, same thing have been explained. So we have class, we have defined a class called dog, name and age. So we're given, self name, self, age. These two variables are initialized. Okay, just to mention the underscore init underscore parenthesis method signature is intended for spaces. The body of this message is intended by 8 spaces. The indentation is virtually important. It tells Python the init method belongs to the doc class. As we know, in Python, we don't use line delimiter, right? So for that, the indentation we are using just to make sure it's a one program block. In the body of init, there are 2 statements using self variable. Self name creates attribute called name and assigns a value to the name parameter. Self.age creates an attribute called age and assigns a value to the age parameter. The attributes created in an init method are called instance attributes. An instance attribute value is specific to a particular instance of a class. So whenever the class is, the object is scrapped, all the instance variable are released and are cleared by the trash collectors. All dogs objects have a name and an age, but the values for the name and age will depending upon the dog instance and will change as per each and every object. That's all about OOPS. I know you have worked on OOPS in your programming these things. So this is a kind of just a refresh. If you want, we can go into the depth. But I believe, let's not waste our time in revisiting what we have already done, right? If you want,
Yes.
I would be, love to share some good links with you on that, right?
Okay. I understand the concepts. It's fine
Yes,
about it.
that's really great. Sure. Let's go to our, oh, come on. Yes, this one. Now, let me take you to another journey as far as, now we are actually stepping into the shoes of actual architect, solution architect, or data scientist to on a, actual real scale. Okay. So we're going to understand statistics and probability and the terminology used in Python. This is really a great need because whenever you discuss your solution with anybody, this terminology has to be used while discussing, because this makes you the data scientist from a programmer, and that's how you can differentiate yourself as well. So we need to use this statistician mathematical terminology whenever we try to explain our solutioning, explain our actual, understanding of solution itself, explaining whenever you're trying to present any data scientist solution, we have to use this terminology at a relevant places, right? Let's try to understand from data. What are the, new data source, or why this data growth is such an exponential data growth? I believe it's a repetition from our, demo class, but let's, go through it again. So what we are trying to do, we are trying to understand the data generation, data analysis, and try to create a solution as a scientist to different domains in the world. These domains can be the retail domain, insurance domain, transportation domain, government domain, education, healthcare, media, and banking. These all domains, they are data intensive domain. They create the data into petabytes of the world or terabytes of the world. So here what we are trying to do, we are trying to provide solution to their huge data problem, or trying to understand or analyze the huge data coming to them on a daily basis, weekly basis, to make sure they can utilize this data up to the best knowledge of the information technology solutioning. Okay, so here these are the 8 major domains we normally address as a solution architect, as a data scientist. Okay, now let's take a step further and try to revisit what we do as a data scientist. As a data scientist, I normally try to club mathematics, business, and technology together and provide a solution to a huge data problem, which will make sure whatever I'm creating as a solution is let the business use the best possible ways and means of technology with mathematical formulas, mathematical functions, and then slowly, steadily, I'll induce artificial intelligence, machine learning, and such type of technology, new technology inducement or leverages to make sure the business achieve its maximum decision-making capability based on our solution. So we do analyze the data on a fly or on a real time and provide solutions to the business in a nutshell. And how do we do that? We build some data solution. We build some solution which are more relevant to the data which we have shared with us, and we try to suggest business with something like consumer behavior, something like which is the best market to try marketing, which is the market with the least marketing expenses, which is the market with the maximum marketing expenses but really good profitability parameters. And that way we normally do use this data science technology to work with huge data in terms of huge number of customers, trying to understand why, how, and how the progress or trend is looking at for the business inductions. So that's why data scientists are really useful for business to strategically plan their advancement. And that's why they get paid really well. And that's how we want to park ourselves in the best usage of business to make sure whatever I'm doing will be the very useful to the business, as much as the business can leverage the profitability or the market spread or the brand leverage or whatnot, depending upon the strategies of the business they want to utilize our data scientist practice for. Does that make sense to you?
Yes, I understand.
Yeah, so this way, that's why we need to understand our portfolio, our work, scope and spread basically, just to make sure we are clear on this thought process as well. Why business are paying a good amount, good payouts to data scientists. It's not easy work, but still, what we are doing, we are trying to collaborate mathematics with technology and trying to help business out to build new data scientists, data scientific solutions. Let's try to understand with a simple example. And these examples available on YouTube. Also, there are quite good number of papers available on this case study as well. Data analyst at Walmart. As we know, Walmart is one of the oldest retail chain, right? So they had a huge shop in every nook and corner as far as North America goes, and they purchase anything in volumes that's in retail, and they sell to a consumer with the smallest possible profit. So consumers felt the goods are coming to them with really cheap price, really economical prices, or best value for their money, and that's why they get attracted to the Walmart. Now let's try to understand. Walmart was thinking of introducing a new product, and he wants Walmart's as a business want to understand where this product will be sold. So we need to understand the consumer needs, consumer behavior here, and where these products can be, transported if they are perishable, where these products can be produced at a least possible cost. So that's again kind of, lowering your cost, increasing your profit kind of thought process here. So there are quite a few number of parameters we need to include, we need to analyze, and if you do it automatically, well and good. But if you do it manually, it's going to, and it will take huge time. And once you have the data with you are ready, then using manual effort doesn't seem fit, right? So we are trying to automate this process. So here, the case study of a cake pops. Cakes pop, as we Indian know, lollipops, or it's a kind of modified lollipop, specifically for they are shared across on a Thanksgiving type of festivals or Christmas type of festivals. Now, these are basically ventured from in North America as a really good way to spread happiness, or good way to spread these things across season festivity. They were really good products to enjoy the positiveness, right? So for that matters, there were many smaller industries, prior to, I think, 2000, earlier 2000. But then Walmart introduced these cake pops into the retail chain, and they were started selling these cake pops in the vicinity of billions of cake pops per season, billions and billions, believe me. And that's how it was really a great success. Walmart leveraging social media data to find about trending products so that they can be introduced to Walmart store across the world. Now, cake pops specifically famous in a Midwest region, which is normally also referred as a Bible Belt, where these are exchanged among all the friends and families during the Thanksgiving and Christmas. It's a simple goodwill gift, and gift is not costly, but it's also eatable. So it's a perishable eatable. So cake pops get bad within, I think, 2 or 3 weeks. It has a cake and a wrapping of a chocolate or some other confectionery sweeteners, so that if they really taste well, they have different look and feels with the colors, as you can see in the photo here. There are various models and various different user aesthetics applied to this model as well. And Walmart studied really well. They built a mathematical model with the data scientist, and then they implemented these data science business alignments for their new product induction. Now again, if you want, I can share the video on that as well, or you can just look at YouTube for popsicle case study for Walmart, and you'll get all this detail.
Okay.
Now let's take a step further. Let's try to understand, from another solutions perspective. There was something called Netflix. When they've started, everybody laughed at them. even the YouTube for that matter. But YouTube is typically for IT people, Netflix is for media people, or rather film enthusiasts or sitcom enthusiasts who are not techie people. So what Netflix did, they analyzed or they studied the market for I think 2 or 3 years throughout North America, and they basically realigned the YouTube model of storing a huge base of all media in terms of movies, sitcoms, documentaries, and all those things at a single place, and try to share a subscription model at that time. It was not a great hit to start with. So they gone in depth. They leverage some data scientific communities. They really developed a competition within data scientists. They spread the word. So whoever gives them the solution, they'll give them some so many $1 million. And these are also case studies available on YouTube as well as on the web. So nothing major in that. So the way the things have been propagated or marketed, they leverage it even today. Means Netflix was a really big hit. Within few years, it reached a subscriber of I think 10 million was their breakneck when they started actually earning something, because media storage is costly, and in those days it was really costly. Nowadays it's getting cheaper day by day, minute by minute, because of we have now that octane, we have the flash memory and everything. But in those good old days, we used to store on hard drives, and then retrieval indexing. It's a really pain as far as having this data to be played. But luckily, the overall internet data bandwidth have been improving by leaps and bounds, and that's what's really beneficial for all such services. Now we have dime a dozen media services like Netflix, we have Amazon Prime, and God knows what not. Even we have IPTV and all those things. IPTV also started in parallel with Netflix, but IPTV couldn't get much steam because it was still a bit techy to have encoding, decoding, and and all those length of parameterized filtering. In Netflix is just flat. You have a menu, select what you want in terms of genre, in terms of timeline of release and all those things. So you have some parameter to filter out, select the media and start playing it. You don't have to need a video player installed on your desktop, laptop, mobile, whatnot. The Netflix take care of it. Same like YouTube. They have their own streamlining video within themselves. And that way, Netflix was really a huge success. And now the Netflix is valued at how many? Like, if I'm not mistaken, quite a good number of billions as far as the worth of the net asset of a Netflix. So it's just a video streaming, media streaming supplier. But it have built the business. They have built the business with all these research data scientists and make it viable. Even if you can think, if you compare them with other counterparts, they are quite the market leader even as of now, after I think around 15 odd years. So and I know everybody in North America, Canada uses Netflix left and right. In India, I don't know why it's too costly, but yeah, in India they're a bit struggling, I believe. So they are trying to get partnered with some other media providers like the cable TVs of the world and all. So that way it depends. Means even simple model couldn't work everywhere. So they are still working on this Indian or South Asian economical media services type of model. So they are still studying. Might be within next couple of months or in the next year, they might be hit in South Asia as well. So let's see, God knows what not. Okay, so please do have a look at these case studies. If you want, I can share these videos with you also, or we can play them and discuss them at length as well. The motto here is to understand how data scientists are helping business, and that's why I have shared these basic two examples with you, which are really a great success story. Walmart Popsicles and Netflix media distribution service. And they have really planned it well. Means even the solutions are available up to a great extent on GitHub. You can utilize those solutions if you want to create another, using some products with some other, what you can say, retail organizations. or if you want to build your own media services, how to go about it, and how to do the research, and how to analyze certain region for certain media services, you can still go and understand or rebuild such models by yourself as well. And that's the beauty of it. We can rethink this whole thought process. We can understand from their experiences, we can learn from their experiences, and we don't have to really go through it again and again. Every business growth is a painful, because you need to build a brand, you need to tackle the product, raw material, productions, delivery, customer satisfaction, and every whole 9 yards of it. So building business is never was a cakewalk. But with the data scientist team, we can leverage all they can with us and build a better business strategy day by day, hour by hour, and we can set up some automated mechanism to help us with all these strategic help we need to market better, to market in a specific region, and to understand how the customers in that region behaves. And this is what the actual gist of the business in terms of gaining the brand name, utilizing the brand name for the profitability, and so on and so forth. So you can create a really good business as far as all these data models can guide you. Does that make sense?
Yes.
So what we do as a data scientist, how do we help business, right? So we use statistics, we use programming language like Python, we use data extraction and processing, we use a huge data, bigger database called big data and all these things. We do data wrangling and explorations. We use machine learning for the repeated task and let the automation does it, magic after we did it once. So we build some repetitive data model. That's where the OOPS also comes in. Then big data processing framework like big data, their data access, efficient data throughputs models, and all those things. And we also create data visualization. So we built some graphs, we built some pie chart, we built some really good looking image visualize representation of the data, so that business can take decision based on those visual representation. As simple as that, right? So data scientist does all these 6-7 tasks just to make sure whatever solution we are devising, whatever solution we are incubating is helpful to the business. Let's try to understand from a data life cycle perspectives. So how does data life cycle progresses? We normally sit up with business, try to understand their requirements in terms of what they are looking for. Are they looking for to the consumer behavior? Are they looking for cost cutting? Are they looking for top line building? That's what we call increasing the profitability overall. So how to acquire the data which is need to devise this solution? So for consumer behavior, we might sit with a support or consumer satisfaction unit in a given company, try to digitize this data available. If it's already digitized, so well and good. We acquire those data as an for analysis purpose. We did a processing, a kind of cleaning up, data aligning, and then we do a data exploration. So what does customer in, let's say, Midwest region, St. Louis region, is reacting to our new product calls, is reacting to our discounts or sale during Thanksgiving, Christmas, New Year, this and that festivals. We build some model which will basically make us, and as a data scientist, understand how we can benefit from these data exploration. So where should we target our next product to, or what should be our next product to, so that the Midwestern region can be well aligned, or they will jump on our product like a hotcake. And yes, we do some user acceptance, and we then deploy this thing to the actual market, and just help the business as a data scientist to achieve their goal, be it a market building, be it a market spread, top line building, cost cutting, and all those things. So we understand the problem, we identify the central objective, identify the variable that needs to be predicted. So all these 6 steps are normally included in our data life cycle as a data scientist. We start with a business requirement, then we move to data acquisition, data processing, data exploration, modeling, and deployment. So these are the 6 major steps. So if somebody asks you in an interview, how data scientists help help to business in terms of data handling, or how they basically support the business in terms of data life cycle, or explain the data life cycle in typical data scientist solutioning. So these are the different 6 steps we normally should be able to explain. You can have your own thought process, you can make them 7, 8, 10, 15, whatnot, but these are the 6 steps normally as per me are standard, and they covered all the steps. Again, if you go to different site, you might have different number of steps they've covered in their data life cycle as a data scientific solution. Okay, so here we are trying to build better and better alignment with the data availability, how to use them to the best possible knowledge. So we perform these six steps. We try to understand business requirements, what they need, what they are looking for. Then we acquire data related to the requirements. We process that data in terms of trying to understand how we can support the business requirement, or the best possible way to address the business challenges or the business requirements which are mentioned to us. We explore the data. We try to understand in terms of trend analysis, in terms of pitfall, in terms of cost spending, if you're doing cost reduction and all those things. So we explore that data as per the need, as per the business requirement or the business alignment. Then we build some data model to make sure the data models are to help solve business requirements, to address the business problems, business issues like cost cutting, like proactive consumer behavior building, or strategic for some seasonal produce or seasonal distributions. These are type of models which we normally devise, and then we deploy these models to the market, or we deploy the solutions to the market to help the business to gain profit, gain much better brand or much better market reach. So that way we basically can explain how data scientists are helping business to solve their business challenges or business strategic objective. Okay, let's well, I can go on and on about this, because this is the basis of overall data scientific solution building. So unless and until you're clear with that, the next steps might be a kind of incrementally challenging to understand. Do you understand? Means, have you understand this problem, ma'am? Well, how we
Yes.
support the
Yes.
business community? Okay, great, no problem.
Yeah.
Try to speak it out in your words. Try to build your own thought process around how data scientists help the business. Okay, and then you can basically understand in depth once you start to build your own thought process around it. Okay. Next one is, what is data? Let me do one thing. I think let's stop here, because we are now getting into the actual nitty-gritty of how data to be aligned, what is data, and how we basically build these data, or how do we align the data to the business requirement, and with all the following procedures. What do you think, ma'am? Should we stop here?
Okay, we can stop.
Logical, end. Now it's more of understanding of how data scientist solutions are building. Now we understand what to be built, right? How to help business. Now we are going into the step-by-step analysis of how, as a data scientist, I help the business for their growth, for their strategic objectives and all. Okay, so let's stop here. Let's meet again day after tomorrow, and we'll try to basically take a deep dive into building data scientist solutions. What are the needs? What are the alignments, and how business can be helped with our data scientist solutions. Okay.
Yeah, I have a question. I created the GitHub account, but I don't know how to navigate there.
Navigate it parenthetically. Otherwise, if you go to GitHub, let me open that for you, and then you can have a look at it. I have my own GitHub. I shared with you, but yes, it's really neat. Means not right now. I think it will take at least couple of session, because statistic is really big, this thing, right? Big discussion points. Okay, now this is a GitHub, right? So I'll sign in with my login ID and credential. I signed in and now we land up here. Could you see my screen, ma'am?
I'm in the same screen too. Yeah, I signed and I'm here, and I don't know how to navigate from here.
Sure, sure, ma'am. Don't worry. I'll explain it to you. Okay. Now this GitHub is basically kind of repository. In addition to that, they have migrated to a new solution giving platform. So we have all these codes by different companies, source codes available there. Plus they have a number of guidance in terms of scientific approaches to a programming and blah, 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 blah things, right? So here there's a kind of guide also. If you want to have, you can create a hello world application for your repository and all those things. You can start a new project. I have created one project for myself. Where's that project? War in Ukraine. Okay, I have 3 projects basically: ML, Python machine learning, Python data science Ruby, and PL39 learn. I don't know. Well, this is a MySQL thing which we've discussed earlier, because I want my database to be on a local server, but my source code to be run from GitHub, and this is what we did at that time. It was with the older version of MySQL, so no point in that. So this is how the overall thing. Like, you can have a what can say guide, and it will guide you up to a great extent. Okay. Now there are some pull requests. What are the pull requests? I can basically ask somebody to share their code with me. So these are pull requests. Okay. Now I can search on all of GitHub here, or I can do an advanced search. Let's have a look at it one by one. Code search. I want to search code. Let's say Python. Oh, sorry. Python. What should I search? Git HUB. Oh, array. So I want to search for Python GitHub access. You could read, right, ma'am?
Yeah, yeah.
And I'll say search. Now I'm just throwing a sample. So there are 2 different repository results came to me. One is from Kalber Jacob, automation. This looks like a kind of Russian guy or somebody. He was updated on 25th August 2020. And then I have Ujjwal Saini 07, my Python file. This is my normal Python file, blah, 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 updated on 20. Oh, this is the latest. So let's try out this one. So I'll click here. Okay. Now, yes, she have quite a few number of Python code here available for me to look at. And if I want to look at something like, and there should be somebody who takes me how to use GitHub for Python, because that's what I search for, right? So I need to search for, come on, CSV, calendar, image, loading, notification, chat. I couldn't find any GitHub thing. I don't know why. My Python file. Okay, for that matters, if it's there, I can see. Or there's a MD file also. So MD file basically is a text file. It's empty. Okay, so I can go back. No worries there. Registration form. So she have made a registration form. It's the entry box, button, and all those things. So let's try to understand this code. So what I'll do, I'll basically, she's using Tinker. Okay, so from here, what I do, I'll just copy these things. I'll paste it on my, whatever code I use, Spider and all, I'll try to run it out. So this Ujjwal, and I can basically, I don't know how to connect, or, there's a way to connect to this guy as well. Or basically I can send, if he or she have not shared with me, there's a, when I double click this, there's a pop-up comes in. Do you want to set up a pull action? So you can request them. So it's pull like request action. So these pull requests are kind of, please let me view your code kind of access, or give access to your source. Okay, that's thing. Now the other one is advanced option. You can search for the owners. So I can search for this Ujjwal, or if I know anybody else, I'll search Ravindra Pandey, whatnot. What are the repository I'm looking for? If I know the date of creation, any specific language, and so on and so forth. So there are these advanced search. So you can search for a typical entity, if you know, and you can search for, let's try to do something for DOT or BOSTON DYNAMICS. This is one of the most robotic, AI ML type of organizations in Boston, right? So I want to search for their these things, software availability on these things. So I'll just put one, and I'm basically looking for English, so I'll leave everything here. Okay, Couldn't find Boston Dynamics, man. That's okay. So at the end of the day, thing I might be spelled something wrong. This thing do happens. AI, ML. Let's try out these things and let's mention Python. I just want to, basically narrow down my search and I'll say search. No, okay, Boston Dynamics is not a user. So let me delete these things and let me try to search for AI ML.
But I saw, like, I understood, like, you can put your code there and anyone can access it. That's the main thing, right?
You can even limit the access as well. You don't have to make public, you can have a private access.
Okay.
And there are, these various projects and everything available. Now I'm looking for Ujjwal Saini. Oh, he has his photo also.
Yeah.
Oh, wow. Good guy, good guy. Where is he? Oh, he's in Delhi. He has his own, GitHub link also. So he's, wow, joined 2020. Wow, wow, wow. So he's contributing on a larger scale, right? So he's like kind of home and all those things. So we have all this community. And does he work on Python? Yeah, he's on Python. Wow. He work on HTML5, CSS, JavaScript. A good skill set if you talk about this for you for HTML5 books or EPUB developments. This is a really good guy. His email address is also here. Oh, 1947, quite senior guy, but doesn't look like senior. That might not be his birthday. Yeah, okay. That's really difficult to, I'm a cyber hacker, so we normally do this kind of analysis called, user profiling. So these things triggers by default. Pardon me for that. So there are 31. I can follow him as well. There are so many profile views and blah 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 things. Last comment, he have changed 7.3. So yesterday he have added some program. You can follow him on Twitter and all the other things. So you can basically get connected with a user, a scientist, or a community for that matter. Okay, so this way it's a kind of big database of various source code. In addition to source code, they have all the other necessary entities as well. You can ask him a particular question on Python as well. So if I click here, it'll take me to a thing is not working. Okay. No, it doesn't work that way. I think you need to write it on through his email and all those things. So this is the way we use GitHub. Does that answer your question, ma'am? Play around with it so you'll get to know it better rather than me telling you, because these things keep changing. Okay, again, this is a scientific community, so things change really fast.
Yeah.
And that way, even I don't know why I couldn't find out Boston Dynamics. Let's start BOSTONEYLAMICS. I don't know why I couldn't find Boston Dynamics. They have their own
repository.
I don't know. Either I'm doing okay. I got something. Yes. Okay. So I have to search here. Sorry, I was searching at wrong place. Now see, Atlas is another of their robot, and there's something called PyBullet is new one. Okay, this is typical. Just
Hello? I lost the voice.
Supporting file as well.
Oh, I think I lost your voice, but now it came back. Okay.
Oh, there's the internet problem. Pardon me for that. This is I don't know why it's happening from last session, but yes, I have talked to these internet guys. Let them resolve those things. So try to play around here. Try to find out your likings, your where you want to venture as a data scientist, and you'll get all the resources needed here. Means you can copy program and try to play around it with it and all.
Okay. So if we have programs, we have to put in the top left-hand side, right? Our projects, our own projects.
Yes, ma'am.
Okay.
A project is a bundle of source code, right? And if you can create as many projects as you want, but this project disintegrate those folder structure for you.
Okay.
So that way, if I have one project, and I have another. This means that the source codes are a bit different, and I don't want to get jumbled up with this product or this source code with that source code. That's why I keep it segregated. So you're creating your own hierarchy directory structure within GitHub as far as the project goes.
Okay.
Okay, chalo. So I believe you got enough ammunition to get start with that.
Yeah,
Okay,
yeah.
so let's try play around with it. Try even that oops wala program couple of times, so you'll get all brushed up and ready for building solution as a data scientist. Okay,
Sure.
chalo.
Okay.
Let's stop here at this moment, and next class let's get started on how we start building the statistical model for our data scientist solutions. Okay.
Sure. Okay.
Thanks a lot for your time, ma'am. Have a
Thank
good
you.
night. Take care. Bye.
Have a good day. Bye.